How's everyone doing today? In this lesson, we're diving into something electrifying. Literally, I'll be introducing and demonstrating the concept of the electromagnetic railgun, a futuristic weapon that swaps gunpowder for raw electric force. Let's rewind a bit. For centuries, gunpowder has been the go to way to launch projectiles, but it comes with a few big issues. 1. You have to carry the gunpowder with the projectile, making it heavier. 2. It's risky, explosive, and hard to store safely. 3. It maxes out at around 4,000 feet per second. So, what can we do better? Enter the railgun. Instead of chemical explosions, it uses electricity and magnetism to hurl projectiles at mind blowing speeds, up to 52,000 feet per second. That's like 16,000 meters per second. That's over Mach 6. No boom, just zap and zoom. But surprisingly, railguns aren't new. In 1918, French inventor André Bertrand Vimpe created a small electric cannon. During World War II, German engineer Joachim Ansler proposed a full-scale electromagnetism anti-aircraft gun, but it was never built. Why? It needed so much power it could have kept all of Regina's lights on through a long winter night. Now, fast forward. The US Navy spent 500 million on a railgun project. Prototypes worked, but it was shelved in 2022. It was too expensive and complex. They rotated to hypersonic missiles and laser weapons. Boring. But, anyways, let's get to the main part. So, what is a railgun? A railgun, also known as a rail cannon, is basically a big electric launcher. It uses electromagnetism force, not explosives, to shoot projectiles at extremely high speed. It's like a giant electric circuit that turns magnetic energy into kinetic destruction. Now, how does it work? And the components. A railgun has three key parts. Power source. It delivers millions of volts of currents. 2. Parallel rails. Long metal conductors, positive and negative. Armature, the projectile or a conductor that pushes it. Now, let's go on a long journey. Electricity flows from the power source into the positive rail. It crosses over through the armature, completing the circuit. A magnetic forms and the Lorentz force, we'll get to that, slams the armature down the rails at crazy speeds. Some use armatures, plasma armatures, where metal vaporizes and becomes conductive gas. Mind blowing. But alas, while the idea is genius, the reality isn't easy. It requires huge power demand. The rails heat up and melt from resistive heating, and it has a massive recoil and rail damage. Many break after just a few shots. Okay, let's get into the physics now. Here's how the magic happens. Electric current plus magnetic field equals the Lorentz force. This force pushes the projectile forward at insane speeds. The Lorentz force formula F is equals to I multiplied by L times B. where F is the force, I is the current, L is the rail length, and B is the magnetic field strength. More current and longer layers equals more force, which equals more speeds.
Engineers have test-fired a railgun prototype for the US Navy. A railgun is essentially an electric circuit. Its main components are parallel rails and a power supply. A projectile package completes the circuit. A current flows through one rail, across the armature, a part of the projectile package, and back through the other rail. The current generates a magnetic field that is perpendicular to the plane of the rail and armature. The current and magnetic field interact to create an electromagnetic Lorentz force. The force accelerates the projectile package up the rails and out of the railgun, at which point the circuit is broken. To understand how a Lorentz force works, hold your left hand in this position. The magnetic field flows in the direction the index finger is pointing. The middle finger, at a 90-degree angle to the index finger, points in the direction that the electrical current flows. The thumb, forming an L with the index finger, points in the direction of the force. The Navy expects the railgun's projectile to have a speed of 5,600 miles per hour, more than twice as fast as an artillery shell.
Where can you find one? Sadly, you won't find a railgun at Canadian Tire. They're mostly experimental on military tech at the US Navy, defense contractors like the BAE, General Atomics, or the military R&D labs included in China and Russia. Even today, they're hard to deploy. They need so much energy, even modern ships struggle to power them, unless they're all electric, like the Navy futuristic DD destroyer. But a company called ArcFlash Labs is selling a handheld Gauss rifle GR1 for $3,375. It's literally the world's first handheld electromagnetic weapon available to the public. Like something straight out of Fallout or Quake. Maybe get yours soon. Here, just for fun, railguns in anime and science fiction. A popular anime called A Certain Scientific Railgun has a main character called Misaki Mikoto, who flicks coins using electromagnetic force. It's basically a railgun in human form. Lightning, flash, and stylish. Now, also, in Gundam series, they have powerful weapons. Strike Freedom Gundam has X-Phase railgun cannons on its hips for high-speed attacks. Railguns are great for fighting, piercing armor, and saving energy in contrast to beam rifles. In short, railguns in anime, sure, their physics is loose, but it is fun and flashy, absolutely. It's stylized and awesome. Thanks for joining me today. And in conclusion, as a wrap up, so there you have it. Railguns replace explosions with electricity. They fire projectiles at up to Mach 6 plus. The science is real, but tech is still catching up. And anime? It's already there. Thanks for joining me today. Have fun.